Okay, so we did an example where we had a roller coaster car come down and onto a circular loop. And we had the radius of the circular loop was h over 3. Starts at height h, mass m naught. Now let's ask, what is the normal force on the cart when it's at that location? So the normal force is obviously normal to the surface, so in that case it's downwards. So it's same principles, right? We need ma equals f, the vertical component of that. So what does that look like? Well, if we did a free body diagram, we would have Fn downwards and force of gravity downwards as well. So we have minus Fn here and minus m naught g there. And the left-hand side is the same, except that it's not that way. It's always toward the center of the circle. So in this case, it's downwards. We have minus, actually, let me give myself some space there. So it's minus m naught times v squared over r, and that's an unknown v squared. We divide that by the radius, which is h over 3, so we end up multiplying by 3 there. So this tells us that Fn is equal to, I'm going to bring this to this side, is equal to, I'm going to bring this to this side, and so it's going to be 3 m naught unknown speed squared over h minus m naught g in this case. And so the next principle that I need is energy conservation to find the speed. And that looks like same as before, m naught gh potential energy at the beginning. The difference here is that we're again at some height, and that height is twice h over 3. So there's an m naught g times 2 h over 3 potential energy, and the rest is kinetic. So we have an m naught, there's the unknown v squared over 2. So we're going to solve for that v squared, and so we're going to bring this to this side, so we'll have an m naught gh minus 2 thirds m naught gh, and then we'll divide the mass, multiply by 2, and we'll have our v squared. So we have 1 m naught gh minus 2 thirds m naught gh, so 1 minus 2 thirds, that's 1/3. So we have m naught gh over 3 equals m naught v squared over 2. And so v squared will be equal to 2/3 gh. And so we'll plug this v squared into this equation, and we'll get 3 over h m naught times 2/3 gh minus m naught g, and that gives us, the 3's cancel, we get 2 m naught g minus m naught g, and that gives us m naught g. And we see that the force, the normal force is less because gravity is actually helping to push the object downward, less than it was when the object was here.